Okay, so this is an update on this Conlog BEC21 that I'm busy trying to hack. So what I've noticed upon taking it apart is that there's a bit of an oops here. This elastomer, or zebra strip as it's known, was basically forced in here. It came like that from the factory. So it made some contact and obviously was missed in the quality control before they welded it closed, which is it's a bit of a bummer, but I'll fix that. That's just the plastics which I'm putting one side. I will reuse that. I've started working out what's going on here. So basically you've got on the left here you've got a transformerless power supply. It's a standard design. This is textbook. This is classic textbook. You've got a resistor and a capacitor acting as a reactance. It's basically to drop the voltage, and then you've got D6. I'm not entirely sure that's a Xena. I suspect it is. It's not exactly marked well. It's a Chinese part, I suspect, so I don't know what it is. What's really interesting is that you've got the live coming in here, which goes straight to digital ground, and then is part of this via stitched ground plane over here. So that's basically all of this is hot. So this is all sitting at 230 volts. So if you have any leakage in the enclosure, like moisture and you're barefoot, you're going to feel it. The other concern I have is that there's absolutely no lightning protection whatsoever here. There's not an MOV in sight. So that essentially means that take this to Johannesburg, and I doubt it'll make it. It'll last one summer. It'll probably be blown to pieces by December, knowing the weather up there. Yeah, but that's all it really is. What else can I tell you? So I thought that was an EEPROM. That's actually a voltage regulator. So that drops what appears to be about 15 volts over there, which is 3.3 volts for the microcontroller, which is cool. So we've got R26, which is that resistor over there. Goes through that diode. And what's really cool is that I guess it's a consequence again of them allowing the engineer or the software developer to do work on the benches. They've broken out that VCC to a header there. So that means I can put a 2-pin header and supply voltage, and then I can connect that into my Renesas tool, and I should be able to debug this thing, which is really awesome. That is really making my day. It means that I can definitely hack this completely and write custom firmware for it. Only other noteworthy things I can say is I don't know what that IC does. I can't seem to identify it. I'll worry about it later, as I will also worry about the NFC from there at some other time. I don't need these things right now. The only other thing I can really remark on is that this appears to be the H bridge, particularly these 4 transistors to actuate this relay. And this is a bistable relay with a single coil, so put plus and minus one on the terminals in one way, and it'll basically latch closed, and if you reverse the polarity it'll latch open, if I can explain it that way. Yeah, I don't always have the words, struggle with the language today. But that's all there really is to it. There's not really other comments I can make. So it's forward and onward. Yeah, that's all I can say at this point. So I haven't had much time to really go further. Other things I've remarked about is that there's a shunt there. So there's no current transformer, nothing like that, or no Rogowski coil or anything like that. So this is a fairly cheap and cheerful loss leader.